Cassandra Lunch 72. Today's topic is going to be on Databricks and Cassandra. Realized I'm not sharing my screen or sharing my face, but go ahead and turn that on. And my name is Urban Patel, and I'm an engineer here at Anant, and I'll be giving the topic as well as the introduction. So our co-organizers for this event are Rahul, myself, and Josh. We are always looking for people to present at Cassandra Lunch, but even Data Engineers Lunch, which is our sister event on Mondays. Or also, if you're interested in sponsoring this event or Data Engineers Lunch, feel free to reach out to Rahul, myself, or Josh, and our emails are linked below. We are part of Data Community DC. Data Community DC promotes a inclusive culture, so no matter your race, gender, sexual orientation, etc., everyone is welcome, and we expect the respect to be given to all. Data Community DC is made up of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, is under Data Wranglers DC. If you're interested in more about Data Community DC, you can find out more on their website, as well as their blog, but you can also find out about all the various different events of all other various organizations on events.datacommunitydc.org. So what do we cover here in Cassandra Lunch? We essentially cover anything that is Cassandra, talks CQL, CQL compliance. So that ranges from open source Cassandra, DataStax, Astra, Enterprise, Yugabyte, Skilla, Amazon Key Spaces, Cosmos DB, and anything that's kind of in the surrounding ecosystem with Cassandra. So like anything big data, real time. So like Cassandra Spark Kafka are what we do at Anant, but those a lot of times play into companies or people who use Cassandra. So here is generally a quick, if people want to say hello that are new, just looking through the participants list. I think everyone's been here before, so I won't, so I'll go ahead and move on. Group rules, if you have a question, ask it. Be polite to others. This is a community, so we enjoy and we prefer if you have something to add to a conversation, don't feel shy about it. So if you want to add something to what the speaker's saying, depending on the speaker, they have their own ground rules in terms of either if they prefer it in the chat or if they prefer it just speaking up and asking it. And again, just to mention, this is a community, so please do share what you know with us. Here at Anant, we focus on big data and analytics platforms, real-time data and analytics platforms surrounding Cassandra Spark Kafka. So Cassandra Lunch is kind of our bread and butter. So DataStax is a partner and a sponsor. GW University, or George Washington University, is also a sponsor, especially when we have in-person events. They usually provide venue space. We also have some organizational and program sponsors. If you're interested in sponsoring this event, you can get some free advertisement on these slides. Here we have some quick announcements. If anyone in the audience has any jobs, meetups, hackathons, etc., they can drop information in the chat, or they can speak up if they want to promote anything that they have going on. Okay, let me just pull up the chat while we're waiting on that. Okay, it looks like there's nothing. A little promotion for ourselves. Anant is hiring. We are hiring for full-time or part-time positions relating to data platform operators, engineers, and architects. You can find out more and apply at careers.anant.us. So some upcoming Cassandra events. We have some topics related to deploying Cassandra using the DSC operator to Kubernetes. And then we'll have the next cycle of events for November in the next coming weeks. Some data engineers lunch topics. Again, as mentioned, on Mondays at the same time, we have an introduction to Apache Livy. I believe Obi will be giving that talk. So if you're interested, you can find out more at our events page, anant.us/events. And you can find all of these videos now that we're streaming live to YouTube via Zoom currently, but all of these videos are automatically added to our YouTube channel, youtube.com/AnantCorp, and then they're manually added to the Cassandra Lunch playlist. So if you're interested in the Cassandra Lunch playlist, again, this is number 72. So we have, I think, from 10 on, so at least 61 Cassandra Lunches that are available on our YouTube channel. And you can go ahead and bookmark that playlist as well. And Cassandra.Link is a hand-curated knowledge base for all things Cassandra, but then also things that talk Cassandra, like Cassandra, Spark, and Kafka. And this is hand-curated by Rahul with new links being added on a frequent basis. So if you read everything on Cassandra.Link, you're probably a Cassandra expert. All right, so that will wrap up the introduction. I'll go ahead and switch over to my slide deck for today. Can everyone still see my screen?
Yeah, you're good.
Okay, so as mentioned before, some ground rules. I don't have any preferences in terms of if you have a question or if you have something to add, you can feel speak up. And if you're watching this on YouTube, feel free to drop any questions you have or comments in the live chat. And someone is monitoring the YouTube live chat and they'll port them over to the Zoom. And today's topic is going to be data. And we discuss how we can connect Databricks and Cassandra via a couple different ways, but the main portion of the demo is going to be using DataStax Astra, so that way this entire demo you could replicate all in your browser. We would like to ask if you are not muted, please mute yourself if you don't intend on speaking. So yeah, if you haven't watched our previous data engineers launch, the one I actually gave an introduction to Databricks, that's available on our YouTube channel. But quick introduction to Databricks, it's one unified platform for data and AI built on Lakehouse architecture. Lakehouse architecture is kind of their method of data warehousing, like their proprietary method. And they have a free community edition, which is a micro cluster manager and notebook environment. That's what we'll be using today. So one thing about the community edition that I do want to mention is we can't run jobs, so we can't schedule jobs, etc. But for the purposes of playing with Databricks and Cassandra, it's more than useful. And with Databricks, you get reliable data engineering, SQL analytics. So if your team has BI analysts or business analysts in general, collaborative data science. So with the amount of data that people use machine learning, Cassandra is often a viable data storage for machine learning algorithm or machine learning training. And if you're interested in machine learning and Cassandra, one of our team members, Obi, has given a series on it. You should be able to find that in our playlist sections, or you can just find it on our YouTube channel. And because Databricks is a fully managed cloud service, you get that security, reliability, scaling, and performance that comes with a service like that. And Databricks is rooted in open source. So the people who started Databricks are the people who originally created Apache Spark, like Delta Lakes and MLflow. And then you have other technologies available within Databricks bundled in. So like TensorFlow, Redash, R, and I believe Koalas as well. And so what today's talk is mainly going to be focused on a demo. So in this, we're going to use Databricks Community Edition. We're going to use DataStax Astra. If you're not familiar with DataStax Astra, we have tons of content available on our YouTube channel. So feel free to search DataStax Astra on our channel and you'll be able to find a ton of different videos and topics. So DataStax Astra is also a free tool, or there is a free tier in a sense where you don't have to input a credit card. They give free credits. And so it's a perfect way to get familiar with DataStax Astra without, or DataStax or Cassandra in general, without having to download anything to your computer and do everything in your browser. And so the main topic of Databricks, or the main focus of the demo today is going to be on doing reads and writes on Astra from a Databricks notebook, and we'll show you how to set that up so that way you can replicate it on your own. So first things first that we're going to do is we're going to go ahead and spin up a cluster, and then we're going to talk about some stuff while we're waiting on it. And so once you're logged into Databricks, again, Databricks Community Edition, they also do not ask for a credit card. So knock yourself out playing it. It's a perfect playground. So if we go into the compute section, is generally where we create clusters. So the Community Edition auto terminates after, I think, 2 hours of inactivity. So we'll go ahead and create a new cluster. And so we're also going to name this cluster Astra, right? Because we're talking to Astra. So one of the things about Databricks runtime that I want to mention is because we're talking to Cassandra, we'll need the Spark Cassandra connector from DataStax, right? So depending on what version of Cassandra you're running or you're trying to talk to, you'll need to spin up that version runtime in Spark. So Astra generally is like the latest version of Cassandra. And so before, I think a couple months ago, I think in July, the Spark Cassandra connector didn't have Spark 3.1.0 compatibility, but they did a release in July that added it. So what we're going to do is just pick this defaulted version of the runtime. But again, depending on your Cassandra, if you're running Cassandra 3 or 2 or like a lower version, you can pick and choose what runtime you have, so that way your compatibilities line up. And if you go to the Spark Cassandra connector, so actually just pull it up here, Spark Cassandra connector. And if you look at the compatibility table, you can see what you need for what, right? So right here is what we're focusing on. We're using Spark 3.1. Astra is probably on 3.x or 4.0. And then Spark, or then for our connector that we'll need to put onto our cluster will be the 3.1. So if we go back to Databricks, so we're going to select runtime 8.3, Scala 2.12, Spark 3.1.1. And then one thing also that we'll need to do is establish some stuff for the demo, which is our Spark config. And we can do that, and say if you want to add more variables to the Spark config, you can do it at a later time. So say, oh, I'm missing something, I need to add it to my Spark config. Once your cluster is running, all you would do is just come to the edit option. And then once you put in the new items, it'll restart the cluster. So that way the new Spark config options will be available. So the options that we'll need, let me go ahead and copy and paste it in, are DSE continuous paging enabled false. The reason that we have this is that sometimes there can be some read errors from Astra. So essentially just having this set to false will help avoid that error when you see it and when you run a cell. This is more specific to the demo that we're doing, but essentially I have a database spun up in Astra, and we'll take a look at it in a minute. So my database name is Astra, and our key space is called test. And so this Cassandra auth password and this Cassandra auth username, those come from the tokens in Astra. So these are some tokens, they'll be deleted after this event, but essentially those are the username and passwords that you'll need to talk to Astra. And then the final thing you'll need to talk to Astra is the config bundle, right? So Astra has an auth packet, like a zip file that you just download, and then you can use it either in your code, or if you use it in Databricks or anywhere you need it. Essentially just provides like the host names, contact points, et cetera, et cetera, et cetera. And so all we need to do for that is just provide the path. And you see how I have the path dbfs, file store tables, et cetera. I'll show you what that looks like in a minute, how to do it yourself. But just so I can get this running in the background, I'm going to go ahead and start it. So let's go ahead and hit create cluster. And so while this is happening, we'll also install the library that we'll need for the Spark Cassandra connector. So if we go into the library section and hit install new, there's different ways you can do it. So if you just download the jar, so if we go to releases on the Spark Cassandra connector, We can straight up just download the jar, or we can search for it, right, in the Maven or the Python package index. So for Maven, we're going to go ahead and hit search packages. So one thing to notice is that you see how it defaults to Spark packages here. So if I search for just Cassandra, you see how there's only one version available. So the thing I've seen in the past, I don't know if they've adjusted for it yet, but sometimes there are some compatibility errors between Databricks and the connector. So there's a version of the connector that we should use instead of the normal just Spark Cassandra connector. And then also, if you notice that the releases only contain 1.x to 2.4. So if we go back to the releases here, the table, right? So the options that they're offering to us, Databricks, in that specific view, are essentially for this and down, right? So if you're using Cassandra 3.0, you can't use that package. So what you instead can do is change this portion and go to Maven Central. So here, if we do Spark Cassandra connector, we should now see all the different versions, right? So we're seeing 3.1, 3.1. And if we click on the dropdown, there's more options available, right? So as mentioned before, there's the normal version, right? And then there's also this version that says assembly. So what I've seen in the past is that the assembly version works better for Databricks and Astra. I can't speak to the same for Spark and maybe, Databricks and potentially a cluster or a node spun up in AWS, GCP, etc. But for us in connecting Databricks and Astra specifically, we're going to use this assembly version. And again, just looking at the releases, we're going to use 3.1, right? Looking at the compatibility chart, we're running Spark 3.1, we're running at least 3.x or 4, and we're running Scala 2.12 from the runtime that we set up in Databricks. So we're going to use the connector version 3.1. So we're going to go ahead and select this, and then we're going to go ahead and install. So our Databricks cluster is already up, right? So to then, as mentioned in the configuration section, to have this DBFS file store, what you can do is go into the data section, and then you would hit create table. And when you hit create table, you can upload a file, like drag and drop, and then you can put it where you want to, right? So if I go to my Astra dashboard, and if you want to, I'll show you how to download the auth packet. So this is my Databricks database, and I want to hit connect, right? And then I'll go ahead and hit connect using a driver, and then we can download the bundle, right? So then if we want to import it into Databricks, all we do is drag and drop, and then it'll automatically upload it to where we need it, right? So now if we go to DBFS tab and we go to file store, tables, we'll see these options, right? So this is the one we'll be using, which I uploaded the other day, but this is the one we just uploaded, right? Because it's the second version, so it has the one. But essentially, this is like an old one I had for an old demo I did back in the day, but this is the one we'll be focusing on. So essentially, it's literally the path. So if I click on this, I can copy this path that shows up down here, and that's what we have in our compute cluster, right, in our Spark config. So if we go to Spark, we have DBFS and that path. And again, as mentioned, if you need to edit the config file, you just hit edit, go to Spark, make your changes, and then when you click out, you can hit confirm. But because we're not making any changes, we'll just make sure the library is installed. Great. Now, to replicate what I'm doing right now, what I recommend in Astra, before they didn't have this, so we had to import our own data, but now DataStax has like example data that you can you can add yourself very easily using CSV, but you can also import data that they have preset for you. So if you go to the load data section, the one I'm using is restaurant locations. And then if you hit restaurant locations, hit next, it'll give you about I think it's 1,500 rows. And then you can select what items you want as your partition keys, your clustering columns. So essentially make up your own primary key from the various data that they give you. The one I have set is partition key is state, clustering column is location, and then you would just continue down to load to target database. And then essentially they'll just send you emails once it's done, but it generally takes less than like a couple minutes. So going back to my Astra dashboard, we'll go ahead and connect to the CQL console. And just to verify with you guys, we're just going to do describe tables. So we see in this key space test, we have this table called Chipotle stores. And again, that's the table that we loaded using that method. So now what we can do is go to our notebook. Let's go to the Astra one. And you can upload notebooks to Databricks as well. So if you have some workloads already written in like an IPython notebook, either via Jupyter or some other notebook, you can drag or you can upload into Databricks and have them persist, right? So what we're going to do here, because we're using 3.1 Spark and 3.1 of the connector, we're going to be using the catalog method to talk to Astra. But even if we're not talking to Astra and we're just talking to Cassandra, we can still use the catalog method depending on the version of Spark and Cassandra you're running. So what we're doing here is we're importing some libraries that we'll need. We're setting DB name and key space name. So again, this is, as mentioned before, those specific things in the Spark config were set up just for this demo. So again, my database name is Databricks, and my key space name was test. And so those will be pulled. So essentially we're setting the catalog here, and then we're saying use Databricks.test, and then we're going to run a show tables. So when I hit run, or actually wait, we need to attach our notebook. Okay. And our default language for this notebook right now is Scala, but we'll talk about that later in a couple minutes. So when I run this, we should get back our Chipotle stores table. Okay, Spark key space name. So it looks like there was some error. So what I'm going to do here is just detach and retach. So let's try this again. And if this still fails, we have to go look at our Spark config. Maybe there was something messed up in the copy and paste. Okay, so let's go ahead and go to our Spark config. This will load for me. All right. So we see that here, for some reason, it combined database and key space, or database name and key space name. So we'll go ahead and edit this, right? So we'll go into here. So this is database name, and then spark.keyspace.name. So our Spark key space name is test, and Spark database name is Databricks. And then we'll go ahead and try this one more time. And just get rid of extra spaces. Let me go ahead and just move one of these down so that way. Wait, why is there a copy here? Let's try it like that. Okay, let's see if that works. So let's go ahead and hit confirm and restart. So now if we hit this, so we have key space name test, database name Databricks. Okay, cool. So now once this cluster reloads or restarts, we should be able to access it again. So while we wait on this, what I do want to mention is there is a way to import data from Cassandra that Spark offers, like a preloaded template notebook for you. But I do want to mention some things about it, right? So if we go to a workspace, this is a Cassandra example. So you can load this. You can load this into from like I think it's when you search for data, and then if you hit create table, other data sources, and if you hit Cassandra and create table in notebook, so it'll give you this template. So if you look at these instructions here, this is mainly for, this is like an AWS example. But again, you can put in your own, because again, this is just a template. So if we look here, it says create a Maven library using Spark Cassandra connector, whatever, right? Currently it's set to 2.4.1 and 2.11. So Scala 2.11, Spark 2.4.1. So again, looking at the compatibility chart, it's preset to this, the instructions that they're offering. So this is kind of where it comes in, where it's like the methods that they're using here as well. So, right, they're using like, okay, so they're using data frames. So I think it still would work fine. But so you would just, depending on what version of Cassandra you're running, you may need to just adjust this Spark Cassandra connector, right? So version assembly or the normal one, because again, I can't speak to a deployed on like AWS or GCP or Azure. But you can try this template out if you have something spun up somewhere, and just make sure that you're using the right compatibility based on the chart here. So based on your Cassandra version and your Spark version, pick the correct connector version. So moving back to compute, okay, looks like our cluster's restarted. So we'll go back to our notebook. And we'll go ahead and detach and reattach. All right, and if we try running this again, ideally, we should get back our Chipotle stores. All right, it's running the command. Let's give it a sec. Taking longer than it normally does, but we'll just give it a minute. Let's see, in the meantime, we'll just confirm. So select count from test.chipotle stores. So we're working with about 1,500 rows as mentioned before in our Cassandra pre-loaded import that we used. So if we go back here, so now that this is run, we see that in our namespace, quote unquote key space, we have a table name called Chipotle stores. So now, if we were to run the same exact thing we just did previously, so do the select count by using Spark SQL versus the CQL console and Astra, we'll do the same thing, but then we'll also do a select star from that specific thing. And for that, the way that Spark will show it, it'll just show the top 20 rows. So again, just confirming 1521 and 1521, so those match up. Oh, connect. And then we see whatever rows, right? So we see Utah, because again, we're partitioning based on state as the partition column and location as a clustering column. And then we have Colorado. All right, so now what we're going to also do is, well, actually thinking about it, we should probably have address. So there's, it's fine. It doesn't affect what we're trying to do right now. So now that we've done this, what we're going to do is extract all the Chipotles that are in Virginia Beach. So we're just going to confirm which ones are available. So we're going to do select all from Chipotle stores where state is Virginia and location is Virginia Beach. So if I go ahead and run this, we should see a data frame with 1. So currently in the data set, there's only 1. So now if we go down, and what we're going to do is use that data frame we just generated using Spark SQL, and we're going to create a Cassandra table in our key space, because again, we've set our key space here, we pulled it from Spark config, and then we're going to create a table called Virginia Beach restaurants. So the idea is just to variously attach or talk to different, say if you have different franchises, right? You have one for Chipotle, one for McDonald's, one for Wendy's, whatever. And we just want to, by state, again, depending on your data model, this is just getting used to it. Again, this demo is probably not, doesn't make sense to do it in a quote unquote production environment, but this is just more so to show you how to talk with Databricks to Cassandra, more specifically in this case, DataStax Astra. So for what we're going to do here is we're going to create a Cassandra table. And then when I run this, once it's completed, we'll go ahead and check it in the CQL console. So one thing to notice is that we got this warning that it's saying that this create Cassandra table method is deprecated since 3.0.0, which is fine. We'll talk about this in a second. Whereas you can use data source v2 catalog API. So if we go here and go to our CQL console and we do a describe tables, we'll see our Virginia Beach restaurants that we just created via Databricks, and I talked to our Cassandra instance via Astra. So now what we can do is, now that we have this created table, we can run that query that gets the Chipotles that are in Virginia Beach, and then write that into that specific table. So what we're doing here is we're doing the value. So that this is the data frame that we generate here. We say write in Cassandra format, Virginia Beach restaurants, and then our key space, and then mode append and save. So when we run this, see our Spark jobs. Okay, looks like it went through. So if we now go to here and we run a select all from test.Virginia Beach restaurants, we see that single record that we pulled from earlier. So now if we go to back to Databricks and we just do the same thing, but we're confirming it via Spark SQL instead of CQL that we just did, and we get back the same data. So now what we can do is we can drop that table. This command may not complete, but it's fine. It'll still drop the table. So I'll just give it like 30 seconds. If it doesn't complete, we'll go ahead and kill it. Okay. Let's go ahead and kill it. And then if we go into the CQL console, we do describe tables, we see that it's now gone. So it does work, it just doesn't complete the job in Databricks, or Spark more specifically. So now what we're going to do is kind of in vein of the warning that we got previously, where it's saying that create Cassandra table method was deprecated. Another way we can create tables is straight up SQL, right? So because our default language here is Scala, we can use a magic identifier to say we're using this language, right? So instead, if I wanted to write a Python function, I could just do quotient or Python, right? So when you have this set, it's saying we're using this language in this cell. So what we're doing here is we're saying create a table. And again, so instead of doing it via the data frame, we actually have to say what things are what, right? So we have to say first column is a string, second column is a string, third column's a string, fourth and fifth are decimals, right? So we didn't have to establish this when we did it directly via the data frame using create Cassandra table. But when we were doing it with the SQL statement, we say using Cassandra, and then we do a partition by. So our partition column is state, and our clustering key is location. So we use this table properties item. So if I go ahead and hit this, we should see it complete. It'll just say done, I believe, or okay. So now if we go back here and we run a describe tables, we now see this Virginia Beach restaurants again. And so if we do a describe table test, we see state text, location text, address text, latitude decimal, longitude decimal, and our primary key, right? So we have our partition key and then our clustering column. So it correctly picked up what we were trying to do just with the SQL statement versus using the create Cassandra tables method. So now if we go into inserting data, so the nice thing about SQL is we can select from one table and insert into the other, right? So what we're doing here is we're saying SQL, insert into Virginia Beach restaurants, the table we just created, select from Chipotle stores, and then a where clause, right? So where state equals Virginia and location equals Virginia Beach. So when we run this, we get back just once the job runs. But if we do a select all, we see back the same data, right? So now if we go into Spark SQL and just confirm it, right? Select all from Virginia Beach restaurants, we get back the same exact data. So that pretty much wraps up my demo for today of how to connect Databricks and Cassandra, more specifically DataStax Astra. But what I wanted to show you guys is how easy it is to learn it, play with it, and then get better at Spark and Cassandra, learn the basics as necessary. But more importantly, all for free. I didn't have to input my credit card once. And so the nice thing about DataStax Astra is you have a nice budget in terms of the credits that they give you, where you could potentially run workloads on a monthly basis if you're machine learning or running data analytics, depending on the size of your data. But then again, if your data is not that large, you wouldn't be using Cassandra in the first place. But again, I digress. But when it comes to Databricks, pricing may come into play, right? It may not be the right tool for your organization. So you always have to see what's out there, right? You can play with it, do some POCs, but it may not be right for what you're doing with Spark, right? If you're not running work like notebook environment, but again, we're on the community edition, we don't have access to jobs. You can find out more about the jobs in their documentation of how you could run up like scheduling, the way their scheduling works. It's kind of like Airflow, some of the stuff they provide you in terms of UI related stuff and statistics. But again, it may not be the right solution for you guys. However, we just want to show you what's available, what can talk to Cassandra, how you can talk using Spark. Again, this entire demo you can do just using Spark Shell, right? And so with Spark Shell, all you would need to do is -- packages. But when we're using Spark Shell as a like standalone cluster, we won't need to use the assembly version. The assembly version's more specifically for Databricks. If we're using like Spark Shell or Spark Submit, we can just use the normal connector, not the assembly version. But if you're interested more about Spark and Spark and Astra, you can check out our Cassandra real-time repo on our GitHub, or github.com/Anant, I believe. And that entire repository goes through Spark, Kafka, Astra, APIs, Node and Python, and I think a C#. But essentially, all of that entire repo can be done in your UI. You don't have to download anything. Yeah, but I think that's it. I'll open up the floor to questions. If you're watching this on YouTube, feel free to drop any questions or comments in the live chat, and we'll get them ported over to here. All right, looks like there's no questions in the Zoom chat. Josh, do we have anything on the YouTube side of things?
No questions over here either.
All right. We'll go ahead and wrap it up for today. Thank you everyone for joining us. We'll be here same time, same place next week for Cassandra Lunch. If you want to attend Data Engineers Lunch, you can also find that on Meetup or Eventbrite, or you can subscribe to our YouTube channel and turn on the notification bell. So whenever we go live on Mondays and Wednesdays, you can get notified. And we'll see you guys next week. Take care.